Hello, guys. We want to discuss force and the force and Newton's laws of motion. Force is a vector quantity that has magnitude and direction. Force is a product of mass and acceleration. Force can deform a body. It causes deformation of a body. Force can also change the state of a body. Most of the times, people say, which direction will the body move after a force is applied? The force always acts, the body will act in the direction of the force. So if force is applied on the body tends to move in the direction of the force. That is how force acts. Also, force is, it can cause the change of position of the body. That means it can cause a change in velocity with respect to time when it acts on a body. So that is what we call a force. Now, force cannot act on a body and moves and the body moves in other direction. No, it will move in the direction of the force. So the force is a product of mass times what? Acceleration. Now, it is possible that force acts on a body and the body still remain at rest. It means that the force is not visible enough. It's not enough to cause a change of the body. It only causes the body to move in a uniform motion. So it's only when an external force now influences. So according to Newton's first law of motion, which we are going to still look at. So we can force interact with their environment. That means when a body have an interaction with its surrounding or its environment, it is the influence of force. For example, a mango dropping from a tree is under the influence of gravitational pull that act on it. So we can talk about forces and we will not end. Don't forget that force is measured in Newton. Don't forget that force is what? Measured in Newton. So we can have two types of forces. Is either a force is what? Is pull or push. When I say pull or push, means that forces always have contact with the body. It might not be a direct contact. That's why we have what they call field force and contact force. Contact force can be pull or push force. Now, for example, you bring a pin closer to a magnet. The magnet will attract the pin. It means that it has pulled the pin towards it. But if you have maybe two magnets that are like poles, they can pull the pin away, can push it away. The two magnets can be pushed away because they are like poles, like not pull and side pull. So you can have a push, you can have a pull. Now a body is being dragged by a pull force. It can be dragged by a pull force. So basically we say we have contact force, which are tension, reaction, frictional force, and etc. Then we have what they call field force. Field force are what we call the long range force. They are what? Magnetic field, electric field, gravitational field, and all that. These are field force. But basically, we have four fundamental forces that I would like to discuss with you. What are the four basic forces that we have? We have what they call the gravitational forces. Because I told you that an object interacts with its environment. It does mean that what? That there are interaction of a body and its environment create a force. So let us look at this interaction, these four basic interaction that an object can have with its environment or with an atom, with a particle or with subatomic particles. Anything can happen. Now let us first of all start from what we call the gravitational interaction. This gravitational interaction is an interaction of the body with the gravitational pull of the earth, with the force of gravity of the earth, and tends to what? Push the body to the planet or to the earth, depending on the planet in which it resides or in which it evolves. So now, if, for example, a mango is dropped from a tree, we say that mango is under the what called a gravitational interaction. For example, the earth, or let me say the rotation of the earth in a circular motion, is also what we call gravitational interaction. We can also have what? The rotation of the planet around the sun is also what? The planet around the sun, the internal structure of the stars. You understand now? That means the planet is dominated by what? The internal structure. The planet. Let's say the planet domination and the internal structure of the stars are examples of what? Of gravitational interaction. So how the planet dominates or influence the Earth. How the internal structure of the star, how they what? They are arranged, how they are structures. How the structures, we want to study the internal structure of the stars. We are looking at what? Gravitational interaction. We have another one they call what? Electromagnetic interaction. This has to do with electric and magnetic interaction. For example, when you rub your hair with a pen, the shiny part of the pen, you can use it to pick a piece of paper through the help of what? Of electromagnetic interaction. Attraction of a pin to a magnet is electromagnetic interaction. But basically, we can say the force electromagnetic interaction is what? Is the interaction that is responsible for holding atoms and molecules together. That's what we call an electromagnetic interaction. The what? Interaction that is responsible for holding what? Atoms and molecules together is what we call what? Electromagnetic interaction. Now, we have another interaction called a strong interaction or a strong interaction of nuclear forces. This is responsible for holding the constituent of an atomic nucleus together. Like, what are the atomic nucleus? We have the proton and the neutron inside the nucleus. That force that is responsible for holding constituent of an atom together inside the nucleus, which are proton and neutron, or protons together, is what we call a what? A strong what? Interaction, which is also known as nuclear force. Now, a strong interaction is also what? Is 10 power 2 greater than the Coulombic force. We know that when we have two protons, let's say we have two protons in the nucleus of an atom now. These two protons have what they call a Coulombic repulsive force, electrostatic repulsive force. They want to make them repel. And in process of repelling, they can destroy the strong force. But they are not capable of doing that because the strong force is about 100 times greater than the electrostatic repulsive force. Also, we can say that electrostatic force is not the only force that's acting also. We have what they call gravitational force in that atom. Now, between two nucleus or two nucleons, there is a gravitational interaction there. But the gravitational interaction cannot between two nucleons or two nucleus is not greater than what? The strong force. The strong force is 10 to the 8, 38, 39 greater than what? Times greater than what? The gravitational interaction. So strong force is very, very, very strong in holding protons to protons together or neutrons to neutrons together. These are examination questions that you can see in some good questions on necklace. Now, what are also the interaction that we have to talk about? The last one, I've talked about the gravitational interaction. I've talked about electromagnetic interaction. I've talked about strong interaction or nuclear force. So the last one we are talking about is weak interaction. This weak interaction is this force, although plays or act between matters, but do not play a direct part in invisible behavior of matter. It does not play a direct part in the visible behavior of matter. So the interaction among fundamental particles or subnuclear particles is what we call weak interaction, and it forms it forms the radioactivity. That means it's responsible for common form of radioactivity. So if they ask you which of these following force is responsible for the common force of radioactivity, we call it weak force. It can also it causes what they call decays, radioactive decay, like decay, beta decays and all that. Now, but very interesting. If this decay also is responsible for what? The transformation of neutron into proton to release an electron and produce a massless and what? Chargeless particle, what we call antineutrino. Go and watch some of my videos on radioactivity. Antineutrino. So this what, when neutron breaks down to produce a proton and release electron, and with what, alongside with massless and chargeless what, particles called antineutrino. Antineutrino, we said a what, a weak force has occurred in that particular word nucleus, because the neutron is inside the nucleus. Don't forget, the nucleus is what, made up of what, the proton and the neutron. So, and what, why the nucleus is what, shielding there. So take note of that weak force. Now let us enter Newton's what, laws. Now Newton's law, that was what the three laws was explained by Sir Isaac Newton between what, 1642 and 1727. Now these three laws governs what, motion, that governs motion of large what, particles, is studied under the branch called classical mechanism or Newtonian mechanism. Please take note of that. That means that the Newton's three laws of motion governs motion of large particles or large objects, is what we study under the branch of physics called Newtonian mechanism, or what we call the classical mechanism. Now, why the word, when we are talking about studying the word small object, the study of motion of small objects or particles in a small kind of mass form is what we call what, quantum mechanics. While the study of fast moving particles, or that are close to what, speed of light, fast moving particle with the speed of light, or that are close to speed of light, is what we call, is studied under the what, branch of physics called relativity. Now, what are the three laws that this man talked about, Isaac Newton? He talked about what, the laws of inertia, talked about law of what, net force, which is force equal to mass acceleration, which is second law, and force of action and reaction are equal and opposite. Now, the first one is what we call the laws of inertia. That a body will continue in this state of rest or with constant speed or uniform velocity in a straight line unless it is acted upon by external force. That means that, don't forget, whenever this one is talking about net force equal to 0. That means, although in this case now we assume that there is no external force, that's why the body is remaining at rest according to Newton's first law. And we understand that object, what, the ability of what, matter with object of mass to resist what, motion. That means the motion of matter to resist, or the motion of object to resist motion, is what we call inertia. And inertia is the what? Is the what? The tendency of a body that is moving to stop moving, or the body that is at rest, to the tendency to start moving, is what we call what? Inertia. Although we know that what? The frame of reference of this body is what we call the inertial reference frame. That means the frame of reference of this body is what we call the inertial what? Reference frame. Now, that law of Newton's first law that just stated that the body will remain at rest unless it's acted upon by external what? Force, is what we call Newton's what? First law. We have what they call Newton's second law, which is first what? Newton what? Don't forget, in the Newton first law, before I forget, there is the net force equal to 0. And when the net force equal to 0, acceleration is 0, because the body is, we say, we continue to move in a state of rest unless it's acted upon by external force. That means that a force that is equal to 0 creates an acceleration of 0. Anytime the net force is equal to 0, it means the system is at rest, or the system is in what? Equilibrium. So the net force, when it is equal to 0 on a body, I said what? the acceleration is zero, and what? The system is at what? Equilibrium. Now, but second law is that he said the net force acting on the body is directly with what is called what? Product of mass times acceleration, which is the definition I gave ab initio from the beginning of this class. So that is what Newton's second law is saying, that it is the product of mass times acceleration. Or it says that the force applied to an object is directly proportional to the rate of change of momentum and tends to act in the direction of the what? Of the body. That means that the force is always acting in direction, or the motion of the body will act in direction of force, which I've also said about. I've said that when I was talking about the characteristics of forces. So these are what? The second law. This is the second law of what? Sir Isaac Newton. He also talked about the third law of motion, which talk about the action and reaction are equal and opposite. So that is Newton's third law of motion, that for every action there is equal and opposite reaction. You do me, I call it the law of you do me, I do you. So if you hit something, imagine that you have a dog in the compound in your houses, for security purpose, and you hit the dog, and the dog is looking at you face to face. It does not react to the action you are giving. It becomes strange. Imagine the dog looking at you, and you hit the dog first time, second time, the third time, and it does not react. You become afraid that this dog is possessed, because it's not normal. It is not in physics we say that disobeys Newton's third law of motion. Another thing I want to talk about, that if I place a book on a table, for instance, a book is placed on a table, it's under the influence of two forces, reaction and weight. And these two forces are obeying the Newton's third law of motion. So a body placed on a table, or a book placed on a table, is under the Newton's third law of motion. So if you are asked, a book placed on a table is under which laws of motion? We call the Newton's third law of motion. That is what Newton's third law is trying to talk about. And in all these things I've talked about, I've explained forces, that forces are what? Interact with their environment. Forces cause what? Direction. Forces what? Cause what? Change of state of the body, or can change the state of rest of the body, provided what it is enough to move the body. We also say that force is what? Product of mass times acceleration. We also say that force is what can deform the body, can cause change of state of the body. And we say force is measured in Newton is a vector quantity that has magnitude and direction. We have also explained the four fundamental forces or interaction. We have gravitational interaction, which is interaction that is responsible for what? For acting on the body and pulling into what? By what? The help of gravitational force or pull to the earth. We talk about what? Electromagnetic interaction, which is what? Interaction of electric and magnetic field on the body, which we have talked about that it is responsible for holding atoms and molecules together. We have also discussed strong force. We say strong force is a force that is responsible for holding protons together, protons to proton or neutron to proton together in the nucleus of an atom. It's responsible for what? For that interaction of constituent of an atomic nucleus. We have also talked about the formation of what? The common formation of radioactivity is formed by weak force. Weak force, when they occur, it causes either beta decay or alpha decay, which are also responsible for what? For breaking down of the nucleus. Now, we say what? It involves what? Interaction of what? Fundamental particles or subnuclear what? Particles. All this we have discussed. And we have talked about what? That the motion of what? According to 3 Newton's laws of motion, that was specifically what explained between 1642 and 1727. That what? It is motion of large particles is studied under what? Under Newtonian mechanics or classical mechanics. And motion of a what? Of small particles, small object is studied under quantum physics or quantum mechanics. Then what we talk about what? Motion of fast moving what? Object. Fast moving object close to what? Speed of light, or that are moving with speed of light is what we call relativity. Study under branch of physics called relativity. We have explained a lot, and I believe you enjoyed it. Thank you very much. See you in my next video.